Okay, so for this problem, you are being asked to relate a velocity graph to, in the first part, an acceleration graph, and in the second part, a position function. So the first thing I want to do is lay out how velocity is related to these two functions. So velocity is measured in meters per second, and if you calculate its slope, assuming it's a straight line, you are going to get the acceleration. Let me just rewrite this. Because that's in meters per second squared, and that's really adding another seconds to the denominator, which is division. So if you want to think of how a graph's related, division, when you talk about units and their division, they are related by slope. If you want to get position, which is in meters, it means you wanted to take meters per second and multiply by seconds. And when you think of multiplication, that is mathematically related to area. So multiplication problems, when their units are being multiplied, you're relating it to area. When your units are being divided, you're relating it to slope. So what we're going to do first is calculate the slope in each section. So in section A, which is right here, our rise is up 10 and our run is over 5. So our slope is 2 meters per second squared. In section B, we're getting up nothing and over 10 units, which gives us a slope of 0 meters per second squared. And in section C, we are going down 5 units, so negative 5, over 10, which is negative 1/2 meters per second squared. So the first thing that you should notice is that you need to have both positives and negatives. So I'm going to make this right here 0 meters per second squared. And I'm going to count every 2 units is worth 1. So that would be 1, 2 meters per second squared. There's negative 1 and negative 2. Don't really need that line there. Alright, so for the first 5 seconds, we are going 2 meters per second squared. So it's up here. That's section A. And then for section B, we're going 0 meters per second squared, and that's right here. And then for section C, we're going negative 1/2 meters per second squared. That's section C. Well, that's it for this part. So for part B of this, we're asked to calculate the position of the object, and like I discussed on the previous slide, the velocity is measured in meters per second, and your position, which I'll call x of t, is measured in meters. And in order to get from meters per second to meters, you're taking meters per second times seconds, and your unit would come out to be meters. So this is an area problem. It's a multiplication problem. So basically, we're going to find the area under the curve. Initially, the position of the particle at t equals 0 is 0 meters. So really, we're just finding what is happening up to 5 seconds. So up to 5 seconds is right here, and we're finding the area under the graph up to that time. So looking at that, we have the area of a triangle, which is going to be 1/2 base times height. So the area here would be 1/2 5 times 10, which would be 25 meters. And if there were an initial position, we would add it in. Here it's really plus 0 meters. So our position at 5 seconds is 25 meters.